In this question we're going to work out the differential of this problem. First of all, we've got to simplify it into this format. So let's multiply out these brackets on the top here. If we multiply out those brackets, we will get 2x squared, because 2x times x, and then let's do 2x times 4, which gives us 8x. Then we'll do 1 times x, gives us another x, and then we'll do 1 times 4, gives us 4. And these two we're obviously going to combine to give us 9x. So these two here combine to give us 9x. And we've got all of that divided by root x. So now we want to simplify all this, so we get it in the format p x to the 3 over 2 plus q x to the half plus r x to the minus half. So we're going to do 2x squared divided by root x is the same as x to the half. So we're going to replace that with x to the half. We've got 8x, sorry, we've got 9x, let's just rub that out. We've got 9x here, all over x to the half, plus, and we've got the 4 on the end, over x to the half. Now let's just cancel these down. If we divide, we subtract the indices. So 2 minus a half gives us 1 1/2. So we've got 2x to the 3 over 2. So there's the 3 over 2 bits. Good, we've got that. And then we've got 9. We've got x to the 1 minus a half gives us a half. So it's 9x to the half. Plus, here we've got 4 over x to the half, which is effectively the same as having x to the 0. X to 0, anything to the power of 0 is 1. Subtract the indices, 0 minus a half gives us x to the minus half. So we've got 4x to the minus a half. So we can see that we have our values for P, Q and R. Here they are, P, Q and R. So P will equal 2, Q will equal 9 and R will equal 4. Right, in the next part of the question we're going to find the differential. So we're going to differentiate all of this. Now we've simplified it, it'll be easier to differentiate. So we do that, times by the power, 2 times 3 over 2 gives us 3. Think about it, if you're doing 2 times 3 over 2, effectively that's 2 over 1, cancel, cancel, 1 into 3 goes 3. Take 1 off the power, so it gives us x to the half. 3 over 2 is 1 1/2, take off a half, gives us 1 1/2. So gives us a half. Take off 1 off this, we get a half. We go plus 9 times by a half gives us 9 over 2 or 4 1/2 x. Now we take off 1 here to give us x minus a half. Minus half times 4 gives us minus 2. Take off another power, we get 1 off the power, get x to minus 3 over 2. And that is our differential. Now we want to show the tangent of the curve y equals fx, the point where x equals 1 is parallel with this line. So let's find the tangent to the curve. First of all, we don't need to find tangent to the curve, we just need to find the gradient of this. Because if we find the gradient of both of these, then those tell us whether they're parallel or not, because that gives us a direction. If you think of two lines being parallel, is their gradient, how much you go along and then up, how much you go along and then up, that will govern whether they're parallel or not. So if this distance proportionately is the same as this, then you'll have parallel lines. So let's find out f dash of 1. That gives us the gradient when x is 1. Okay, which therefore gives the gradient of the tangent at that point. Now, so if we put 1 everywhere in here, we get 3 times by 1 to the half plus 9 times 1 to the minus a half minus 2 times by 1 to the minus 3 over 2. So what I have done, everywhere here, I have substituted 1. And if we just simplify that, this is 1 times by 3. Don't want to forget my 2 here. This is 1 times by 9 over 2 gives me 4.5. This will come to 1, and 1 to the power of anything is 1, so it'll give me minus 2. So we get 3 plus 4.5 minus 2, and that equals 5.5. So let's just look at what this gradient will give us. Well, we know we can rearrange 2y equals 11x plus 3 to get y equals 5.5x plus 1.5. We divide by 2 gets y, divide by 2 gives 5.5, divide by 2 gets 1.5. And this here gives us our gradient. And we can see the gradients are equal. So the gradient here, gradient of both equals 5.5, therefore they are parallel.